We're on lecture 4 now. 21st February. You have an assignment due on Monday, assignment 2, basically. So ultimately, it's just the sort of requirements doc. And just to be kind of clear on that, teams won't really be changing after that date. If there is a need for a team change, it usually involves taking somebody away and someone working alone rather than like being sent to a new team. Okay, so I've adjusted quite a few. I think every group has had some sort of a team adjustment this week, which is normal. It's expected. Okay, so our objectives today, we're going to do a lot of coding today, really. So I want to go over use case modeling again, not so much to kind of start it, but basically to kind of get you understanding just a few other examples. I mean, you should know what they are. They're very simple. There's only like 5 or 6 components of a use case model, use case diagram, the actors, and the relationships and the use cases. But I think maybe some more examples might be helpful for you. So we're going to look at that, and I really want everyone to be clear on the purpose of the use case diagram, because while some people have a very clear understanding of this, I get the impression that most are just kind of wondering why you have to actually do it. And there is a very clear reason why you have to do it, beyond just keeping customers happy. It has so many more advantages than simply creating a negotiation that the customer gets the product they want, the requirements they want. One of the first obvious uses we'll see is it should help you in creating your database. You should be able to use it as a brief to create your database, to find out what are the attributes, the fields and the table names and the relationships in everything in your database, and if also in your class diagram. So the entire series of UML diagrams really stems from the purpose of this, really stems from writing a good use case spec. So if you've written a good use case spec, you should be able to obviously keep your customer kind of involved and they're satisfied with the needs. But then also a use case spec helps you as the brief to write your database, just like you were given little briefs during your database module. You were given a brief and you had to go and underline nouns and verbs and types of things like that. Do you recall? In your databases module, I mean, you weren't asked to just write the database out of nothing. And then from that, you would be able to write your class diagram. So that's the real sort of reasoning behind doing it. And when I'm looking at these, that will be the success criteria, not just have you written something that looks like a use case diagram or written some words that look like a use case specification, but the real success criteria is 3 things, okay, like I just discussed there. And there's others, there's a lot of others, okay, for clarity and a whole range of things, so that your customer is satisfied, you can use it to create a database, and you can use it to create a class diagram. Now, generally speaking, you should write your class diagram first, but it's okay for this one. So then we're going to go into code. I'm going to spend the second half of the lecture after the break pretty much entirely working through a little car database. So you're going to be watching somebody else code. All right, now I'm recording it, so you should be able to go back to it and type that code. I won't be giving you the PHP files that I've written. I'll expect you to be able to write them yourself. But you can pause this video and have a look and see which ones, you know, just write them out, I guess, from scratch. They're not long. Okay, and that is important for you as second year. I know we're reaching this age of kind of maybe quicker than we think of, like, you know, automating code and rewriting stuff with Gen AI or whatever. But what we're going to do now is I would just expect you to write it from scratch, not this sort of modification of bits of code. Okay. All right, let's move on from there. So just a couple of little logistical things here. A reminder that your CA is due. If you don't know that already, you should. We've been talking about it for weeks and find it on emails many times. But I'll tell you one more time. It's due Monday morning. So I don't know if you have to make any changes to it. If you were in labs the last 3 weeks, you should be pretty much done by now. And there's a little notice Maria's given me, so I don't know what's going on in terms of whether you know this or not, but reasoning why. There is apparently a IT for Business Management lab from 2 to 3, and due to meetings, which I'm attending also, so I presume it's something to do with that, you can come to the morning class from 11 to 1 p.m. Okay, if that involves you, take note. Right, let's move on again. Okay, so Look, this thing about the use case diagram, you know, use case modeling, and what is a use case diagram? What would you say a use case diagram is? Not a use case spec, the diagram, because everything in UML has a purpose. What does UML stand for? What's UML even stand for? Give it a guess. U. It's like UFC. Go on. Say again. Universal modeling language. Yeah, perfect. Universal is the term. Okay. So universal modeling language. So that's not named willy-nilly. It's a universal modeling language named as such, so everybody involved in the system can understand it. That's every programmer, every engineer, and really every stakeholder. Now, every stakeholder is not going to understand the nitty-gritty of classes and class diagrams, but there has to be some diagram in there for the non-technical stakeholders to understand. And what are they called? See board. Okay? So the use case modeling is something that the user can understand. Universal modeling language is going to model everything in terms of what your system can do. But I mean, at the moment, you only have a few diagrams that you can draw upon. So you can see how these look. They have like a sort of actor there on the side, the student. You can also see that it's not overcrowded. It's just the general big picture kind of structure, the look of things. It hasn't got a lot of detail in there. I noticed in labs, people seem to be putting in as much detail as they can possibly imagine, trying to make the thing look better. But that's not what it should be. It should just be very simple, one or two actors, a handful of use cases which we're drawing upon from your requirements. Okay, so a UML, unified modeling language, universal modeling language, use case diagram is primary form of system requirements for a new software program or whatever that's not developed yet. Okay, so everybody can follow what's going on. So it basically specifies behavior. It specifies this word what, the what of the system, rather than the how. So we're not looking at like the details of how it's going to be done. We're looking at the what. So this is back to everybody should be able to understand it. Everyone should be able to understand what's going on. And jumping into questions, jumping into terms like even database, and we're going to use PHP and we're going to use MySQL object to connect. That's not what the purpose of this. You wouldn't even be talking about class diagrams and object-oriented programming here. It's just what is the end behavior. And this is really important because one of the things I noticed quite a lot of people doing, in fact, I would safely say I noticed at least half of the groups doing this, is you're trying to skip this step and make a database. Well, if you haven't done a use case spec and you haven't done a use case diagram, and you're not really intending to because you couldn't care less about the 5 marks it's only worth, where are you going to get your database from? Where? The customer? Will the customer be involved? Hardly. Yeah. Hardly if you don't have a use case, you've nothing to show them. Is the other stakeholders involved? Is every programmer involved? No. So what I'm seeing in labs is some groups have gone and done a pretty good database. It's actually all right. It's not too bad. However, if you dig deeper, you'll see one person has done the database. And if you dig deeper again, well, you don't have to dig deeper at all. If there was a customer involved, the customer wouldn't have a clue what the use cases are because you've just got this database there. Do you see what I'm getting at, right? So the use case diagram is for the purposes of sitting back and making sure you really are doing what's required and not just putting the database first. And yes, maybe you're great at databases and you can whip up a database in minutes. Okay, we're going to do that today in the second half of the class. I'm going to whip up a 3-table database and connect them all in a few minutes. Yeah, that's fine. But the real question is, am I, as the techie guy, doing the right thing? Am I doing the right thing? Am I creating the right what for the customer and the other stakeholders? Do the other team members understand this database? Have they put their input into it? Do you understand? Why are you in group projects? That's why you're in a group project, okay? Because I don't understand what you're doing until I see a use case. And I'm not going to because you can't just go to your customer and say, oh, well, here's the database. Oh, yeah, but I don't really like doing those use cases. They're a bit of a pain. So you can see what I'm doing in the database. Isn't it obvious from the database? You're a programmer, you're a lecturer, you're supposed to understand this. And yes, of course I'll understand it. But will another person understand it who even is another programmer? Will you make sure that you've kept it flexible enough under this agile methodology that we were talking about? And I think the answer to that would be, what do you think? A resounding no, wouldn't it? Okay. Right, so your use case models, make sure it's really clear on the what. I've talked about it a lot, and I'm going to do a little poll now to make sure you're awake for starters. And secondly, how many use cases do you have? So let's get VBox engines rolled up here. Okie dokie. So where am I? Back to sessions. Sessions 21st Feb. So this question, how many use cases in whatever your current iteration of it is? Okay. How do I give you the looking at full screen. There. Okay. So how many use cases in your current iteration? Don't go saying, oh, well, I plan to do 4, but at the moment it looks like an absolute state. Tell me what the absolute state looks like. I'll try to keep this somewhat safe from strange comments this week. I'm not sure. No, they weren't too bad. They were all right. Yeah, maybe if I come away with a new 3-letter acronym, then it's been a success. Yeah. I'll use it on my kids when I go home. Hey, NGL. All right. Shouldn't take you long. Another minute. Are they coming in? 32. So, oh, the music. I forgot the music. Let's get that music going. Oh, I can't play music. Permission, yes, you got that. There you go. That'll wouldn't really wake you up. Put you to sleep. Okay. Okay, so here we go. 4 to 6 is the majority there. All right. 4 to 6. Good. This is looking good now. So 7 to 9 is probably a bit too much if you're in that category. A bit too much for this project. Be all right if you're in work somewhere, but this one's a bit too. 4 to 6, I'd say it'd be good. And 10 plus is whoever you are. Thank you for your honesty. And person on 1, yeah. It's often you can write 1. It's actually somewhat easy to fall into the idea of doing 1 use case. Just the use case is the system output. You know, I mean that's kind of what a use case is, isn't it? Use case is the Amazon website. End of. In some ways, that's more helpful than having 10 or 12. Do you know? Mm-hmm. No, you wouldn't take into account non-functional requirements because they're not. That's not a behavior. Use case is behavior. So you wouldn't use non-functional requirements. No, you can name them in some details, but generally not. No. Okay, let's move on. So a lot of points about it. Use case diagram. It's usually simple. It shouldn't show a lot of detail. So an online shopping system or a check-in system for a hotel or booking or something like that, like you've used these systems. You should know that they're not overly complex. They're not supposed to be overly complex. No one's going to use Airbnb or Booking.com or like Aer Lingus website if it's an absolute nightmare to use. and there's too much different behaviors you've got to kind of perform to get your task done. Like an online shopping, with the amount of competition, I mean, if you look at some of them and you can reuse, I mean, you could practically, I'd say you could probably, if you'd used some of like sort of a food ordering system, probably in 2 or 3 clicks, have a drone deliver something to your house. Do you know what I mean? You just click, oh yeah, that's my favorites. It knows your favorites and where you live, just bump, bump, gone. Do you see? And you can have a delivery in 3 clicks. So the behavior should be simple, which means the requirements of the user actually also ought to be simple. But there is relationships to be thought of. So it should be very simple, and especially in your case. It can get complicated. I think for games, it gets really complicated. I'm a big fan of games. I mean, coding them. I know a lot of students love to play games, but being a gamer player and a gamer coder and tester are really different. It can get very complicated because the number of use cases gets huge for games. You wouldn't realize it, you know, when you're playing a game. The number of variety of screens are so different, but that's the beauty of a good user interface. But anyway, these aren't games. We're doing things like shopping, check-in, sports results, and all that stuff. And they don't really need to show much more than some use cases, actors, and obviously the system. A lot of people are missing the system. The system does some things like updates the actual stock. It checks for dates. It checks if it's Valentine's Day. So you get 10% off your thing you're buying. Okay. And you should all do that. I think you should all put in a non-functional requirement of sales. It's a really obvious one that's easy to test. I mean, non-functional requirements, things like the colors, sure, but that's pretty boring, and it's really nothing to do with us over here in computer science. Plenty of other faculties which are better at that sort of thing. I mean, you may be good at it, but a professional kind of designer will be better, do you know? So leave that to the professional graphic designers. Your job is to worry about things like minimal clicks, minimal works, not too many screens, intuitive, number maximum, a lot of ways to achieve a goal. That's a non-functional requirement. Like, had you actually write that in a use case? You don't. But a very easy non-functional requirement is things like the age. Maybe you have to be over 15 or over 18 to join your thing. A sale. There's nothing much interesting happening for a while. Like we had the Christmas. Before Christmas, you have Black Friday sale, and Thanksgiving, and all the other festivals that are happening. The holiday period is like loads of different festivals happening between November and December. There's loads of things going on. The chaplaincy is really good at this. They know what every single world celebration is going on every week. They seem to come up and something's happening somewhere that is cool and interesting. But for you guys, when you're demonstrating, like, you know, try and get like maybe May Day sale, St. Patrick's Day sale or something like that. Do you get the idea? So put something in there when the time, like the normal price might be €100, but since it's like St. Patrick's weekend, we're giving everyone 20% off, and get that calculated. Does that make sense? And when your CA3 is due, I think it will be around St. Patrick's Day anyway, so be handy to shove that in there. And then if there's nothing happening in May, we'll just make one up. We'll pretend it's Halloween or something. I don't know. Okay, so just don't dress up. Or you can. Maybe that would be fun. Pretend it's Halloween in May. So it doesn't need to show the order. I know a lot of you are very concerned and I wasn't really too worried if login appeared at the top or login appeared at the bottom. It doesn't have, the order is not what's important. It's not about the order. It's about the use cases, the behavior, that it actually specifies the behavior. So we can therefore specify the use case spec, which is good to specify what the customer's needs and the class diagrams and attributes and database and on and on and on. Okay, so don't get too caught up in the order. If it contains more than 20 use cases, you're pretty much missing the point. Okay, which you seem to all get in the little poll. Thank you very much. So here's another example of online shopping. It's pretty simple. You just view stuff, you purchase stuff, you check out, and you register. There's not much else to say, really. And I suggest everybody add their own little feature, like your own little unique selling points, like returns or reviewing products or reviewing the reviewers for the sports people. The sports people's website have to go a little step further because It's like Reddit. Anyone use Reddit? These little self-appointed experts, little self-appointed tyrants that go on Reddit and tell everyone what to do. There is no good opinions, but the Reddit doesn't allow you to grade someone's opinion the way Quora does. So if you compare that to Quora is like, you gotta say who you are. Okay, so I go on, I start talking about PHP and software engineering as a teenager. You're like, fine. Okay, you go on and you say, well, you're the professor of Cambridge or someone who wrote the books. Well, that's a lot different, okay? Or maybe how many actual reviews have you done? Have you gotten rated from all the other people? That's probably the easiest way to do it, especially with something like music or sports. Sports is and politics, those ones, everyone has the dog on the street has an opinion about that, like, do you know? So you can make up something about reviews such as rate the rater. So I think that would be a very easy one to do also. I'm not saying everyone should, but if you're doing reviews, you can put 5-star review or write a little comment. But I think when you review the reviewer, that makes it very interesting. And I can tell you that's actually, you're in a great position for that, because it's not in the interests of social media companies or YouTubes or Quoras or Reddits to really rate the raters, because they'll put the trolls off, and they don't really care whether you're a troll or not. They want eyes on Reddit. That's quite frankly what they want. Do you see what I mean? So that's a bit harsh. Maybe that's a bit harsh. However, like YouTube, let's take YouTube as an example. Anybody can comment on YouTube, and they don't even show you the dislike button anymore. You know, the little thumbs down button on YouTube. Do you see that? Yeah, and you can look at someone's profile on YouTube, and you don't know what else they've commented on. You wouldn't even know if they've commented at all on anything else. It's very difficult. You might say on this channel they've commented, but it's very difficult to see what that actual YouTube comment is coming from. It could be coming from a 14-year-old, you know? So, like, I can see why they don't want to do that on the likes of YouTube or something like that, but maybe you can do rate the rater. When it comes to sports, if you can see, okay, well, this person's been on this website for 10 years. They have put in over 100 well-considered and well-thought-out reviews of the games, and they have been given a 5-star rating by other users. Okay, that's someone maybe we'll listen to. All right, so. Okay, now, you don't have to do that, but I'm just suggesting to take it beyond the simple buy something. This is the very basics. And even the registration, while you will include it in your use case, it's not something I'm actually going to grade for testing or coding, because it's part of web dev server that Rob does. Okay? So realistically, if you just have purchase, it's not enough. It's not that complex, really. But from what I saw, anyway, you all just said you had somewhere between 4 to 6 use case specs. So you should have more than enough in it. This only has 4. You were all saying you have 6 or so. This is an awful lot of actors, registered customer. I'm not sure I would have so many actors. We'll just break it down simply as customer. I guess they're using PayPal and a whole bunch of payment services. Right, UML diagrams, there's loads of them. There's a lot of UML diagrams, and essentially they are all static representations to represent 2 things. You have the kind that represent behavior, which are not static, the kind that represent structure. So you've got the sort of structural stuff, the scaffolding stuff, and you got the behavioral stuff. You've already done a couple of the structural stuff. You've done a class diagram, I believe. Is that correct? How many people among you could say you could write a class diagram? Show of hands. I literally was speaking to Orla about this yesterday. I was torturing poor Orla, asking her, how much did they do? Can they do this? Can they do hierarchies? Can they do? So let's see hands. How much can you do? Can you all do a class with no relationships? You can't write a class with no relationships. Could you write a class for an object called book? Right, a little exercise here. I'm not sure if I have time to do it. Let's just try and do it really quickly. Okay. Excuse me. What about a login for social media? Just a login system for social media. How many use cases do you think that's going to have? And you can talk me through this now. A login for social media. How many use cases is it going to have? I'm going to ask you to tell me what that should look like. How many actors has it got? A login for social media. Okay, that's what I want to do here. Draw a use case diagram. I should have said diagram for a login for some sort of new social media platform. And you can use actors, you can use use cases, you can use relationships. There's only 3 elements of a use case diagram: actors, use cases, relationship. What will I call this first actor? Good, that would be a good start. User. What will I call this other actor? For a social media login, let's just call it the system. System checks you out in the database, right? What are we going to call this first use case? What's the first thing you do when you go to your Instagram and you're not signed up yet? You sign up like you want to sign on. So you've installed Instagram. What's your next step? Let's even say on a desktop. I know you don't use it on a desktop. Nobody uses Instagram on a desktop, but you can use it if you wanted to. So what's the first thing we would do here? I'm just using Instagram as an example. I'm not a big fan of. I've no loyalty to any of them. But what's the first thing you see when you log on? What are you presented with? I just typed Instagram.com and I get this screen. Okay, so you're presented with a home screen. So maybe we can start with that. Okay, so then it's like what? Remember, it's not what you see. That's a non-functional requirement. The way it looks and the fact that it's got this lovely sliding photographs on the left-hand side. What's the first behavior I have to do? Like I have to type in something here. Okay, I've got to type in some type of some type of a username and password here. Okay, and this idea of show, these are all little details, but ultimately, what do I need to do? Well, it can't be that hard, guys. You need to log in, right? So, yeah, exactly. Well, see, I do have an Instagram account, so let's pretend TikTok. I do not have a TikTok account. Can you use TikTok online on a desktop? So if I go to Instagram, I have a ready-made account. Now, look at TikTok. TikTok's a little bit clever. They actually let you see things first. Okay, you can actually sit and scroll. They're really trying to get you hooked, aren't they? With their little dark path. At least Instagram has and Facebook doesn't let you see anything. But what do I have to do here? So the first thing I need to do is click login because I don't have an account. Okay, so I go here and I log in and I'm like, I don't have an account. So what do? I sign up. So then I'm going to have to do some type of an extension here, and that's where I get this. So I'll need to do a kind of an extends. I'll need to do extends some kind of a sign up. You with me on that? Okay, so extends what? Well, extends the sign up. Now, I don't want to spend all day doing this. I just want to get just a general. You sign up, or what we would probably call register. Now, register, spelled wrong there. I don't know what they're asking you, but we'll have a quick glance and see what they're asking you, because there may or may not be information you want to give. So it's got options here, includes, so you have a lot of other options. So this would actually be a lot of other extensions. Extends, use Facebook. Extends, use Google. Extends, use Apple. Or let's pretend we have none of these. We don't know what Google is. And we'll say, I'll use my phone. Now, this is asking for a phone number. Okay, now, like, Gmail does not ask for your phone number. You can set up a Google account without a phone number. Now, this is explicitly asking you for a phone number, and it's planning to give you a code. So if you register, whether you like that or not, that is going to include sort out your phone number stuff. Doing something wrong here. there. So register, I'm doing this really weirdly here, but I'll keep it small. Register includes, we can pop it there somehow. We do it slightly different because it's an easy arrow. It's just one arrow. And notice that the includes just goes in the other direction. Okay. So register will include this business of phone number. Okay, anyway, I'm not going to continue the whole thing, but like, what else would you do there? You can see it yourself. So phone. So that's a sort of a non-negotiable one with TikTok. I don't think Instagram asks you for your phone number on sign up. I don't think they do. We can check. I think they just let you away with email. So if you say sign up, oh, they do. You have to have a number. So it's some of the others. I don't know. Maybe some of the others. I know Gmail does not insist on a phone number. It's two-factor authentication. But this is okay. I'm not going to go through all of this, but ultimately, you'll see that you'll have to do a sign, and then I suppose ultimately you are going to be presented when you finally sign on. You can make a profile should you like. You don't have to make a profile, as in put your photograph and all that business. So that would be, I would say, it's kind of like an optional thing, but you may or may not want to do your profile. But this is the way we'll just draw it. So you just draw it like that, like so, and then they've got the system has to register you, and then the system provides you with your feed. Then you're presented, once you write your profile, you kind of see at the end that the last thing you see is some kind of a, I guess what I'll just call a feed or the list of stuff. Even if you've just signed up a brand new account, if you've joined TikTok or Instagram or any of these things, there's actually loads of so many social media things up nowadays that are all competing for the world champion title, like boxers or something, trying to be the next big thing. But they all kind of work the same. And they're all very simple like this, a login of some kind, and maybe register, maybe not register. It includes something like give your phone number, certainly give an email address. And that, like, you have to at least give an email address to sign up for most of these serious accounts. And that would be an include. Okay, and I forgot to write the word includes there. But you can just say it here. So includes, and you notice that this doesn't really have a lot of use cases. It actually only really has three: the login structure, which is really three use cases all in one, the profile, and show your feed. Okay, so that'd be a very common use case for a login system of some kind. I'll just leave that. It's on the video, so hopefully you'll be able to see it there. And I think everyone's going to have to do at least this top bit, because you're going to log in. Has to be extended if the person hasn't registered, and the registration should include some mandatory thing. I don't think it's a good idea to allow people to register on anything by not providing some type of validation. You know, then that's how you get the bots and all those type of things. Okay, so an email address or a phone number or even another account, like you may link it to your Google account, just some type of validation. So I would suspect everybody is going to have this type of a picture in their account, in their thing on Monday. Everyone should have something that looks kind of like that at the top. Not saying that that's going to get you, like, you know, an A if you do that, because I believe you're doing that in Web Dev Server anyway. All right, let's leave that one aside for a second and move on. Okay, as time is ticking on here. So there's the symbols, so you all know that. I want to get onto the coding of things. Okay, so anyway, look, the purpose of the use case, we talked about this at length. You don't need me to keep repeating myself. It's created in an analysis phase. It's a brief description. Only those functional steps get placed here, like the guy on lynda.com was saying, and like I've been repeating all week. It's an analysis of, as it progresses, it can be fleshed out later. It's just the flow and the exceptions, you know, can be added later, or maybe placed in. Each project can adopt. So you get the idea. So use case spec is a sort of a description. Now there is preconditions and postconditions and alternative paths if you want to get really fancy with use cases, but I won't be expecting any of that. All I'll expect in your use case is the basic path, just one description. The thing that's going to help us make the class diagram and the thing that's going to help us make the entity relationship diagram. All right, just like we showed you in all of the other labs. Okay, so here's an example here. So it's ATM use case. Should be easy to understand. Several templates around about this. But if you withdraw cash, you're going to have actors. All this preconditions, postconditions, they are interesting and they're useful if you can get more experience on this. But for the moment, you don't have that level of experience. Just do the basic path. So yes, if you want to really go for gold and do it the proper way, and you're really determined, I want to be one of those people that are spoken about, who does requirements analysis as my job and gets really good at it and therefore is in high demand and highly lucrative, perfect, then go for that. You should be really thinking about that in college, like trying to really figure out what you like and what you're good at. Some people don't like this at all. They just want to code. And fine, that's fine. But you know, coding is only one part of a huge picture in software engineering. Some people find they're really naturally good at this, that they didn't realize they were good at. Or maybe people find they're good at testing and good at user interface testing or something like that, you know? So like, you're not going to find out if you're good at something unless you really try it, okay? So there is a really decent role in the software engineering industry for sort of architects like this. But just for the CA1, just do this. You can see how it looks. The customer enters their card, ATM verifies card. These are all actions. Customer places their PIN code, withdraw amounts. You can see we're getting a whole bunch of like methods for our classes. We're getting classes. There's card as a class. PIN code is an attribute of the class. Amount is the transaction. Transaction has an amount. Customer itself is a class there. So we're starting to sort of see a kind of object-oriented structure emerge just by reading that basis path there. Can you see that? And that's what I'll be looking for when I'm creating this. It's got nothing to do with me or my own personal interest, you know, like that's why I kind of showed you the other voice on lynda.com, just to see I'm not just making this up. The purpose obviously is to keep the customer satisfied, but I don't think that's a very old-fashioned concept. Yeah, just get the customer off your back so they know what's going on. You're bringing the customer in to work with you to get a better structure, to get a better project. But this is really important. So those of you falling asleep, wake up. With 4 sleepy people in the class. We'll take a break in a minute, right? This is what I'm going to be looking at. I'll be looking at your ATM, not your ATM, but your use case spec, and I'll be reading it. And like, it's obvious. Is it obvious to you that a class could be derived from this? Or 3 or 4 classes could be derived? Yeah, it should be bluntly obvious. It's got customer, ATM, customer takes. There's methods, withdraw method, the withdrawal method, verification, yeah, the amount, the transaction amount. So you've got like 3 classes. I can see customer class, I can see transaction class, I can see account class, withdraw object, and all the different attributes are there. Now there may be other attributes, but you can see how a class could be derived from that very easily. Want to open that? Poltergeist or something, The Shining or something like that. Okay, so it should be really obvious to you looking at it. Is that obvious to you? Hands up who looks at that and said, that's bluntly obvious how an ERD can be taken from that paragraph. Who says it's not that obvious? Who says it's really obvious? Like it's clear that that is a well-written use case spec. Can everyone see that, or you all just don't want to put your hands up? Who says no, it's not obvious? Who says, no, I could never. I could read that for 2 days and still not get a table. Okay? Okay. It seems easy enough, yeah. Okay. But were you given it, or did you write them yourself? Okay, good. Well, perfect. Then you'll do fine. You'll be really well ahead of the game then. So good for you. You've done it already. So basically, this is the sort of thing that like you would have been given in your object-oriented class. I presume your teacher, Orla, would have given you some type of paragraph and said, here's the type of classes we want to do. And you got to go through it and underline stuff, okay? and you figure out where the use cases, not the use cases, where the classes come from. You did this with databases where you run through it and you figure out where the tables come from. Is that correct? Yeah. So in those videos, the guy goes through a lot of methods to do that. And you're looking for nouns. We'll talk about that next week, maybe. We won't do it now. But if we look through those set of videos, the same fella there talking. Let's kind of move it on because I'm really keen to get the coding side done today. All right. So I got a couple of quick polls here. Let's just do them. We'll go through these really quickly, get you all kind of involved to some degree. And I want to start the coding section there as well. So the question is, what are the advantages of making a use case spec? Right, so this is going to make one of those nice word salad things, these little word, what do you call them? What do you call those things? The word clouds. Thank you so much. The word clouds. So don't go writing big essays or trying to be all cute and clever with sarcastic comments because it's going to appear in your word cloud. You're going to mess up the word cloud if you do that. So just one or two words. So what are the advantages of creating a use case spec? I'm just really checking if you know. Not much point in me repeating myself. We lost quite a few. I think I'll save the attendance next time for after the break. We lost quite a few. Anyway, preaching to the choir. You're the ones who are here. So who was that chap sitting beside you? There was three fellows right there. They're not back. Tell them I said hi. Okay. All right. Some are coming back there. Nice. Okay, let's get the music on. So that's so cringe. There you go. I guess it's good. Better than nothing. Right. Perfect. Oh my goodness. Isn't that just beautiful? So helps the class diagram. Absolutely brilliant. It's easy to understand. Yeah, clear communication. Scope helps the scope. Exactly. Helps the customer. Helps clarify what you did in the scope. Helps you give a new dimension to the scope, to the what's in. It helps the customer. They're going to be happy. They're involved. It's easier to make all the diagrams, the ERDs. It's easier to do the class diagrams, the fundamental requirements and the visualization, seeing classes. It's easy to become the king or queen. Wonderful. Yeah. Maybe. maybe, if you're a Game of Thrones fan. Okay, clarity, seeing better relationships, brilliant. So the relationships are there. You can use the relationships, and then that moves on for testing. Even the test plan can be brought out from it if done well. So it's not just seeing the classes. You can see the test plan, and then you can see the diagrams are clear. Then even from that, you can start getting onto all these other things. Sorry for those of you who are in the bottom. CA marks obtained. Yes, that's true. Have a good guide. Effective testing. Somebody put that in there. Well done. Effective testing. You can. It doesn't just create a way to get the use case diagram. Sorry, the ERD. It's for testing and every other aspect of this agile iteration. So well done to you for coming up with that one. Yeah. Yeah. Become a king or queen. Yeah. Very good. You can become the king. If you're good at this, the king of requirements analysis. There you go. Queen of requirements analysis. That sounds like a YouTube channel. The requirements analysis queen teaches all about this stuff. Right. So well done to you on that. Let's move on. That's poll 2. Right. So like, you know, you don't need me to go keep repeating myself here. I'll start moving on to the coding section, which is what I really wanted to get done today now. So all those things that you just pointed out there are perfect. You know, it's got loads of advantages. We could just go on and on talking about testing, and helps you with scalability and helps you do your maintainability. It helps you even consider business continuity later on, all these advantages. But the advantages today for you, for CA2, are really these ones here, that it helps you, you know, avoid that customer. I assumed you said you would do X. That's fine, but like that's a very old style, like I say, cover your back type of attitude. We want to get away from that and involve the customer completely in the process. So help streamline the process by bringing the customer in as an actual system developer, and help define classes and database. So those are the 2 success criteria for you just this week in February. Of course, we'll come back to your requirements later and see, well, can you do testing? Is there maintainability in that? Is there scalability in all of that stuff? But these are the 2 for this week, the ERD and the structure. So well done to you getting that little word cloud done up. There's loads of understanding there, it seems. So it's a case of now using it. Don't just, okay, I understand intellectually what a use case spec should be. Let's now put it into practice. So make sure you can actually get your ERD from this. So look, the first thing we're going to do in lab 4 next week is write your entity relationship diagram. So that's you're going to walk into lab 4. I'll put it online on Brightspace in a couple of, maybe tomorrow night or something. Depends how busy I am tonight. I'll try and get it done by end of the day. And I'll put lab 4 online this evening, and you can see that lab 4 will pretty much say, write your ERD. That's what it's pretty much going to do. So if you're starting on lab ERD, just looking into thin air, what kind of tables would I like? Mahogany table? A birch table? No. I mean, you're going to be lost, really. Whereas if you have a good ERD, if you have a good use case spec, you'll be able to derive that among your team fairly quickly. Okay, so let's get that state. So you know what a database is. I don't need to write. I don't even know why I put a slide about databases. You should know what a database management system is. It's creating tables. It's creating relationships between them. We do need to get a class diagram as well, though. It's not just a use case diagram. We also want a class diagram. And this is kind of next week's lecture, but I'll just kind of briefly structure it here. So I'm going to do something about cars today. We'll start with the database. But of course, we'll need to build an equivalent class diagram up. Something that looks a little bit like that one is what we're going to do. I'm not going to do the VBox poll. Just call that out. What's the difference between volatile and persistent storage? Yeah, it goes away. So volatile storage, yeah, it's temporary, right? So when you lose power, it disappears. You turn your computer off, it just goes. It's memory. So when you buy a computer down in your PC world and it says, okay, we've got this much RAM, That's your memory, your random access memory, right? And what happens when you turn the computer off? If you're not online or anything, if you're using Excel or you're coding and you haven't saved your work, you haven't saved your Word file, you're writing up your CV in Word, you've been at it for an hour and a half and you didn't save it, you haven't got autosave on, and there's a power cut, Storm Eowyn comes again. Well, it won't be called Storm Eowyn if it comes again. The next storm will be, well, EF, Storm Frederick or something. So Storm Freddy comes and turns your power off. What happens? It's gone, right? So it's all gone. So volatile and persistent storage. So these are the terms you should be using. Not in your requirements, you should be saying, we need some form of persistent storage, okay? You shouldn't be really getting into the words like database or JSON files or binary files in your database, okay? You should be saying things like, persistent storage. It's like something that can store something permanently, okay? So that's the basic idea there that we want to make sure you do, and we're going to do that in the form of a database, okay? So you need to model two aspects of this project. We'll need to model memory, and we'll need to model persistent storage. So basically, that's going to be a database that we model that on. We model persistent storage as a database, and we model some kind of memory. So how are we going to do that? Well, you need to do classes and objects. That's going to be your data structures you use. We're not going to use like arrays or just something that you haven't seen before. We're going to use just sort of just classes and objects for now. Okay, so look, I'm not going to go through this now. We need use case spec to make the attributes the class diagram. Yes, we'll use this and we'll underline everything we need to identify objects and classes. It's a fairly similar process to what you're going to do next week in the lab for the EORD to get coins and whatever for the system. Let's leave this for next week. We're going to end up with a conceptual class diagram, which doesn't really have much indicators beyond the class names and the relationships. Okay, that's a conceptual class diagram. So no mention of behaviors, just a general set of relationships. But, look, to be honest with you, if you were working for a company and you started saying, I'm going to go and do the database first, it would be kind of frowned upon, because you should start with the volatile stuff first, the volatile memory first, the data structures. But that's too difficult, I think, for you to do now in second year, at this point in second year, to just start with classes and nothing gets saved permanently. So I'm just going to flip that switch a little bit now, and we'll start with the EORD, the databases. Is that okay? But just remember, like the kind of best practice would be to start with your volatile memory, because if once things are saved permanently, it's no going back. That's the box. Like, you wouldn't design the box before you designed the thing you're going to put in the box. You see what I mean? All right. Okay. So, an EORD looks kind of similar, and I think for most of our purposes here, it is going to pretty much be identical. So where you have classes, you'll have entities. Where you have associations, you'll have relationships, multiplicity, you've got cardinality, attributes, you've got data elements of fields. Okay, so this is the thing I want to draw up. I probably won't get the whole thing done today, but I'm going to start drawing this class in EORD. That's a class diagram, rather. Car, a sale, a seller. So a sale contains a car. A sale contains a seller. It's the so-called salesman. So the salesman and a car. All right. Seller, sale, car. Sale contains two things there. All right. And then basically you would build those classes. But for now, let's just build the equivalent database in EORD. So you got sale, a seller, person selling the car, salesperson, and the car itself. So sale is the salesperson always gets some kind of a commission on a car. And we haven't included commission in this, but this is scalable enough so later on we can include commissions for the salesperson there. You see what I mean? So we can start kind of having a new table down here called commissions later on, but it's scalable enough we don't have to do it right away. You get the idea? Okay, that's why you walk into these dealerships and they just hound you straight away, because every sale they get a good commission on it. Okay, so what we're going to start with is this class car. So I'm going to now go into the open source toolkit with Laragon PHP-MyAdmin, create a database connection in PHP of a little bit of a mini car sales dealership. And we'll start with the car table and we'll see how we get on. It's always a bit weird coding in front of a class for a lecture. So what I've tried to do is create them all in advance. I've got these 7 files, which we'll just go through. So I don't really want to start writing code from scratch. That'll be a very tedious thing to watch somebody else do, let me assure you. But what I will do is explain the code that I've already written for you. I won't be putting this code up in files that you can just download and run, but I will be placing it as like just on the recording, obviously, and you can just kind of look at it yourself and see how you get on with that. I'm just counting who's all here. I take it back, some people have appeared again. I'm trying to learn as many of your names as possible. I'll get there. All right, let's get on to this coding. So if you have your laptop, you might even consider trying to do this alongside me. So let's start. We have Laragon. So when you load up your servers, you have Laragon here like this, and you need to start your servers. What is Laragon? Is Laragon, what is it? Yeah. The collection of utilities, yeah. It gathers a whole bunch of you. Which one specifically are we interested in here? Apache and MySQL. So as you can see, it's got that started, okay? The database tool it's using can be selected. I think it starts up as HeidiSQL. You've got here MySQL is run automatically by HeidiSQL. I'm not a big fan of it. It's awkward to use fast. So for the sake of speed, I've included PHP-MyAdmin on top of it. So I've just added PHP-MyAdmin to it. And I suggest you do the same if you want to. Well, it doesn't really matter, to be honest with you. If you can make the database in HeidiSQL or PHP-MyAdmin, it's irrelevant. What is important is that you can see your files. So I'll go down to the root directory here. We can see there's the C drive, and it's Laragon, and it's www. That's the root directory. So I put a whole bunch of files in there today. Notice I have version 2 and version 3 as well. Okay, and I've got all these files I'm going to do. So version 2 is the little one we did last week. I don't know if you saw the video that I made for you on Friday, where we just did 2 files, a little pet shop. Do you remember that one? The pet shop? I don't really want to run it again. It's on the video here from last Friday. If you look at it there on Friday's video, I can just very quickly show you where I just had 2 files. Well, actually, no, I'll mess up everything if I start doing pet shops now. Let's just keep it simple. So here's the getting started. It was this getting started video.
Section. I use PHP-MyAdmin, which is here because it's very quick.
And it's in chapters. It's in chapters too, so you can look at these videos yourself. It's in chapters. The structure. All I wanted to show you was the structure of a PHP file. So I basically just echoed out an array of dogs. Okay, that's what we did last week. So here's last week's file. I did a little for loop where we just scroll through this array of dogs, and it outputs to the screen.
As a local host,
looking something.
Open the file.
Looking something kind of like that. Okay, no CSS, nothing. There's a little bit of CSS in this, but not much. Okay, so we just outputted the dogs. So dog 1 to 5 based on the code. And you can
outside of that,
you can see there's the code is we're just adding the little +1 to the. I'm not playing a video. It's fine. Okay. All right. Okay. Just to get the code, just to get the file. I won't play it again. All right. Just this, I want to just show you this. I'm showing you this for the purposes of showing you the file structure. Okay. So the file structure is what I want to show you here. So we have this array which reads through the for loop to just show you a bunch of dogs. Now that's hard coded. And that's not very useful because the dogs can never change and nobody can interact with the dogs. So what we're going to do is do something similar, but with cars and get it from the database. And I'm going to show you how to do that right now. Okay, have you done that far in your other? So I won't play any more videos today. Okay, I just showed you that video so that it was quicker to get the code from the video than get the code from the file. So this is now what our C drive looks like. So we have the Largon directory, and it's got this root directory here, and it's got all these files that we're dealing with, okay? So basically, let's take a look then at what Largon should do. So the first thing I'm going to see is web, and we have all those files. Okay, so if you just look at it, there's localhost, it's running. You want to go outside and have the chat outside instead? Yeah, yes, yourself and the two gentlemen there. Do you want to go outside and have your discussion that way? Yeah, you're distracting everybody else. Thank you. Okay. All right, so let's get this going here. So you've got this series of files, and each one, in a sense, does the same thing. Okay, they aren't really sort of doing anything new. We're just getting deeper and deeper and deeper with each one. So the first one is a database connection. All right. So if I look at them all, we'll just kind of see what they look like. It just successfully connects to the database and outputs a few cars. Okay. This one is going to just do the same thing in a different way, a little bit more sophisticated, and we just do it slightly more advanced. And we're going to just build up then to maybe adding some new stuff. So the first thing we're going to look at is this one called database config, where we just simply connect to the database. That's all we are going to do. All right. So what I'm using here is I'm using this tool, just Notepad++ to show it. Okay. Can you all see that code clearly? Do I need to make it more bold or something? Is that clear enough? Okay. Right. So notice that this does not have any aspects of HTML or anything. It's simply a PHP file. It begins as PHP and it ends with PHP. All right. So it simply has just the bare bones to make a connection to a database. So there's PHP ending PHP. We have a whole list of strings mentioned here, and it's just to really get the connection to the database that we want to do. So did you want to take a break for a bit, outside? Okay. It's got the whole list of things that you wanted to use to connect to the database, and we get that from here. So if you're wondering, well, what on earth is all this stuff that you're talking about? It's connecting to the database. Okay, so what you should basically get here is a sign-in sign. It should ask you for your password, the root password of your machine. Okay, now why is that taking so long? Quite sure why. There you go. Okay, so it asks you for your username and your password. Now on my machine, it's the root and just a null password. Okay, so that's probably what it is for any one of you who's using the phpMyAdmin tool, root and password. In a sense, it's why I'm using it, because it is simple enough. So this is then going to log us on to phpMyAdmin and show us all the other databases that we have there. So you can see there is holiday and there's my database. That's the one I'm going to use today. If we look in the user directory, Largon directory, and if you go to data, we can see there's MySQL 8, and it's got all the databases there. It says Hotel Friday. We'll worry about that. Probably a bit too ambitious to get to the hotel one today. We'll just do the car one today, okay? And there's my database. If we look at my database, it's got a car table inside there. All right, now I've made all of that already, and I'll make another one in a few minutes, but essentially, it's a fairly straightforward thing to do. So let's go to my database, and I'm not going to make car because I've already made it. But what I will do is I'll make the other table that we spoke of, which was the seller. And I'm not going to do sale just yet because this would be like transaction or the sale or the product, like the ATM. The ATM thing we looked at earlier system would be almost identical, but we would rather than call it sale, call it transaction, rather than call it car, call it like amount, because you're just getting an amount of money, aren't you? Rather than call it seller. Well, there is no seller. It just might be customer or bank account holder. Account. Do you see the idea? So what I'll do now is I'll make seller. And seller's pretty easy because it's got seller number, seller name, seller bio. It's not quite as big as the car. Okay, so let's go into that and have a glance how to do it. So I guess I better get around here if I'm going to type it. So PHPMyAdmin has a whole range of things here. We just click on the thing you want, the database, and we're going to go create new table. And I'm going to just call this seller. I'll try to keep it sort of lowercase and some kind of structure. And it's only got 3 columns as far as I can see there. This will ultimately be our ERD, and it's got seller number, seller name, seller bio. So let's try to keep that as close as possible as we did to everything else, because all these words are going to appear in your code. Like, for example, when you connect, you need to say from the car table. There's a bit of SQL query in there. So you got to be very mindful of how you name things in the uppercase and the case sensitivity and all that you use in advance, because it's going to appear in your code. So let's go and do seller. So seller with 3 columns, create, and it does create some SQL code to do this, but this is a tool, so you don't have to do that. It is software engineering after all, where we're trying to get things done quick. So I keep forgetting this. Number, name, bio. So let's go. So seller number is an integer, and I think we need to make that as the primary key. Okay, so let's call that. This is going to place a little constraint to make that a primary key. So just go to this section here called the index and give it the index of a primary key. Okay, seller number, seller name. Sorry, seller. Did I have seller name? Seller name, and that's going to be varchar or something like that. So we'll call varchar. Let's give them like 50 characters there, and it's not a primary key. And I'm going to say seller bio, which is their experience and how long they've been doing it, and maybe make that about 250 characters there. Okay, and that's fine. That looks pretty good. Seller number, we want it as a primary key. Seller name is a varchar. Seller bio as a varchar. So I'm happy enough with that. I'm going to go ahead and press kind of save. We can preview the SQL. Let's just look at that. So it's going to create all of that stuff for us. It's fine, but I'm using this so I can do it quickly in front of you in a lecture. And it's fine if you want to do it this way too. So there you go. There's seller number, seller name, seller bio. Okay. So what we're going to do is we'll look at how the car list worked, and we will add a few cars. So here is essentially the car table. We'll add a few sellers in a minute. Let's see if we can do something similar for the seller. So here's the cars. So BMW, Nissan Micra, Mercedes, and a Bugatti. Let's delete a few of them, okay? Let's just kind of delete the Mercedes, and we'll delete. No, I won't delete the Mercedes. I'll leave the Mercedes, and I will delete the Bugatti. Okay, and it's giving me red. Are you sure you want to delete stuff? Now, I deleted that from SQL. I deleted that from PHPMyAdmin. I don't want to be doing all of that from PHPMyAdmin. You want to be able to do that from your website. So we want to be able to write something in our website called to insert a car from the website or delete a car from the website. You don't want to be doing that from the tool the whole time, from PHPMyAdmin. What's the point of making a nice database? Sorry, and a nice website, a nice database. Even though this is not much to look at, it could easily be built into a decent CSS style sheet and have a user interface and really look like a car dealership quickly. Whereas the database behind it is not so simple. Okay, so let's just look at the codes to do the CRUDs today. So I'm hoping that ambitious 10 minutes, create, read, update, delete in 10 minutes. Okay, so watch this. It's recorded. The code is there. You'll be able to see it. So first thing is connecting to the database. Well, let's just look at a database connection. Here is a file with everything in it. Okay, and we got all this body HTML. It actually looks like something. And if I to look at sample one, this is sample one, right? Database connection. Sample one says successfully connected to the database and outputs your cars. Notice the BMW and the Bugatti no longer appear. Okay, let's put one in and see if it'll appear. Can anyone just give me a car, a relatively normal person's car, not like Bugatti or something? What? Cybertruck. Okay. Let's put it in. As long as it's less than 100,000 euros, I don't care. So reg number. So let's give it a reg number. 22D. 221D 555. It's a Tesla, isn't it? Yeah, Tesla Cybertruck 2022. We'll just leave it as a date. And notice I've made similar things here, the way I've made all those fields. So this is similar fields I've made for the reg. The same fields I made for seller, I'm doing the same. I did the same already for the car. So I'm going to add that. That should be now added. It's inserted, one row inserted. There's the code that's done it for you. If we browse that, you can see there's Cybertruck is there. If we look at the structure, you'll see I built that exactly the same way I just built seller, by adding a primary key and adding in the type of values. But look, the important thing is this, that you can connect to your server. So our server is localhost. We have a password, root password, just like when I logged on to PHP. Then we say it's null character. That's not nothing. The null character is not nothing. It's a null character. And the database name is my database. Be very clear how you're naming it, right? So now we have this string here, and this is a connection object. So we're creating a connection object. So this is basically the MySQLi connection object. I'm not going to put comments into this code today while we're doing it, because I'll probably muck it up if I start putting comments in, trying to code in 10 minutes. So this is MySQLi connect. So we basically have the same things as were above it: the server name string, the username, password, etc. So all the stuff that appeared above it, we have here too. So there's localhost, server name, username, root, password, null, database name, DB name. You got that? There are plenty of ways to do this. I don't know what Rob's going to do with you. Is he done something like this yet? Okay, you haven't got to it yet, but don't worry about it. You may use PDO object. There's ways to do it in Visual Studio. There's ways to do it just in PHP. There's a lot of ways to do this. Don't get caught up by, please nobody come to me with, oh, but you're saying you want this way and Rob's saying he wants this way. No, you can do it any way you want for me. As long as you make that connection to the database. Okay, let me repeat that. For software engineering and testing, you can connect any way you wish. Okay, at the moment, I'm showing you MySQLi Connect because it's simple and it's quick. All right, so go ahead and do the way you're doing it with me to start with. It's only one string and it's a once-off file. So here is the connection. You say if the connection is true, meaning if a database by that name actually exists with that password on that server, then say connects successfully. If it doesn't exist, kill the connection, kill the object, and say connection failed. Do you understand? So if I was to go to this and say this database, 222 database or something like that, and then try and see if it's existing, it'll say the connection is failed. So if I click on that database config, it's failed somehow. It didn't even give me worse than that, okay? So let's go back to that code and fix it properly. Save it. And we want to reload that so it says connection successful. So it's found that database on that server with that username and with that password. Is everyone clear on that? Okay, so that's a simple enough piece of code to write. MySQL database connection, done. So what I've done here is I've taken all of that out of there. I could fill it in there. You could do this, put it in there, and then start working with your database. So I now have a little select statement. Notice that is a string. I declare a string, and inside that string is a SQL piece of code. That's a select statement. It's called embedded SQL. So you are embedding SQL code inside your PHP file. So now your PHP file contains 4 types of languages. It contains HTML code, it contains CSS code, it contains PHP code, and now it's containing SQL code, all embedded, working in unison with each other. Is that making sense? Okay, so you've got to do that, not this weekend, but starting next week, yes. So here we go, we're going to do a connection. There's an object, we just want to make a connection. We use a new object. We use the MySQLi query object. So this is now going to make a query to that connection you just made. So the connection is neatly wrapped up in this little object with the password, the username, the server, the database name, okay? And we're now going to give it a query. So we're basically going to query this particular connection. Make sense? Okay, and this is the result. So I just make a string and I say fetch every line, fetch the first few lines. And then in that row, what is reg number? And I've got to name it exactly as I did in the database. Car make, car model, reg date, car value. Exactly like the database fields. So that when we look at that, you can see inside car, it's named car make, car model, car value, reg date, reg number. Is that making sense? So half of this is attention to detail. It's not particularly complicated to understand, but when you end up with 25 relationships and 25 tables and they all have, you know, their own little attributes, it's keeping tabs on everything. That's the hard part. So let's look at that particular one there. This is doing 2 things. And don't forget, oh yeah, you have to close the connection at the end. So you basically have 4 objects there. We have the connection object, then we have the query object, we have the fetch the first line object, and then we have the close the whole connection object. Make sense? Every single file you do connecting to your database will look something like that. So let's see what that looks like on screen. Here we go. We say connecting to database. It's connection 1, and it outputs all of our stuff. And voila, there is our Cybertruck. Make sense? Okay. So I could put another one in there. Let me put another one in really quickly, just in case you haven't got it yet. I'll put a second thing in there. I'm not sure I'm going to get through all of this today. We'll see. I'll probably get through the reading and the update. Let's just put something separate into that. Why is it taking its time there? Leave it. I don't have time for that. Okay, I'll put some sellers in. Let's just move on. What I've done in the next file is something a little bit more sophisticated. Rather than have the whole connection string in every single file, just make it as an include file. Keep it separate. Do you understand what I mean? You don't want to have that every file pretty much looking like that, having the connection string. Like that's 28 lines of code or 18 lines of code just to make the connection object. That'd be very inefficient coding. So make it a database config file, keep it external, and then include it. And then do it. It's the same file. It's just we've separated it into 2 files. So rather than sample 1 is just this big long file, sample 2 includes this thing called database config, which is the connection to the database to save you having to clutter up your code. Okay, so let's run that now and we'll see it then back. Sample number 2 is not going to really do anything different. There's our Cybertruck. Okay, doke. Right, let's move on and see what else is the next file. The next file is we now want to, as include, it's really no different. It's just the same thing again, actually. It's a little bit more sophisticated in how I've done the outputs. Okay. Let's go back and look at it. Just modify the outputs ever so slightly. As include, slightly more sophisticated layout. That's it. 4 is query the expensive cars. Now you'll see there are no expensive cars. Now I know 100,000 is expensive. I just used 100,000 so people would see it on screen. If I put like 10, nobody would see it from that far away. So there's no expensive cars here. 0 results. So what's being queried there? Well, if we look at that query, and I think we'll finish up on this one. I won't have time to do the update and delete. all you need anyway for the next 2-3 weeks is this much as I'm doing here. Okay, let me get through it really quickly. I'll just go through this code of this. So this is query the expensive cars. So again, include your database configuration. That's the connection. And we're going to build a query. But rather than just say select everything from the car, like I did last time, select everything from the car. This time I'm just saying select where the car value is 120,000, over 120,000. You get me there? So to be honest with you, most of your querying is going to be dealing with strings and inputs from the user and building this SQL statement. You're going to be building up this query that I've just kind of written in here, hard coded. You can get the user to type in that in the text box and build up the string that way. Are you with me? And that's kind of the challenge for you over the next 3 weeks. Right. So I'm saying 120,000 euros just because it's easy to see on screen. So let's put in a car that costs that much money. So insert, I'm inserting a new car. So register, I'm going to put in 251D888, and we will call this, what's the kind of car that costs that much money? Mercedes, I have no clue. Mercedes, brand new Mercedes SLK, something like that. I don't know. And this car is going to cost 150,000 euros. Okay, that's been inserted in there. When we do a browse, it appears. There it is. There's your Mercedes SLK. No, the second one, 150,000 euros. All right. So let's look at that now. When we go back and I reload that, there should be one expensive car that's over 120,000 euros, our SLK. And there it is. Make sense? Okay. So this is just basic CRUD stuff I'm doing. I'm going to kind of wrap up now. There is an insert of a car. We'll insert a Bugatti. So there's currently no Bugattis there. So if I just go back and I scroll through all of them, there's no Bugatti. But if we run an insert, I'll just insert. So rather than using a query, I'll just make an insert statement and insert that Bugatti. So let's go back and run this insert. So insert. Now we go back. It should have run for us. The Bugatti should be there. And no, it didn't run. Why not? Insert car. Okay, new record successfully created. And then when I look at it again, now there's the Bugatti has been added. Do you see that? Okay, and then that's a very expensive car. So when I look at expensive cars again, it's got 2 expensive cars. You get there? Okay, so that's I'm going to leave it there because it's going to get confusing otherwise. That's the basic kind of we did create, read, and update. We didn't do delete yet, but we can get to that next week. All right, so let's leave it there. Well done to everyone today, and I will see you in the lecture and labs next time.